Hi everyone, myself Vidya Kane. I'm studying in Sri Venkateshwara College of Engineering. I am from Basic Science Department from the branch Artificial Intelligence. Today I'm doing my video assignment on mathematics. So let us see my topic. My topics are Introduction for Linear Algebra, Introduction for Critical Point of a Network System, Core Elements of a Network System, and also Example for Critical Point of a Network System. At the last, let us know Python program to find critical point of a network system. First, let us know Introduction to Linear Algebra. So, Introduction to Linear Algebra. Linear algebra is a study of linear combinations. It is the study of vectors, spaces, lines, and planes, and some mappings that are required to perform the linear transformations. It includes vectors, matrices, and linear functions. It is the study of linear sets of equations and its transformation properties. So, next, let us see Introduction for critical point of a network system. A critical point is a point on a surface where a discrete map is not a local homeomorphism. It can be classified as a branch point, a folding point, or a cusp point based on its characteristics. Critical point analysis can be used to define local minima and maxima, to define saddle points, and design numerical algorithms for analysis. Next, let us see core elements of a network system. There are four core elements of a network system. They are nodes, edges, flow, topology. Let us see one by one. First, let us see what is nodes. Nodes represent individual entities like computers or routes in a network, crucial for processing and relaying information. So, next let us see what are edges. Edges are the connections between nodes essential for enabling communication and data transfer across the network. So, next is flow. Flow indicates the movement of information through the network, often analyzed using linear algebraic method for optimization. Last is topology. Topology refers to the arrangement of nodes and edges in a network, influencing its performances and reliability. Let us see some example for critical point on a network system. To identifying the critical point in a network, we have to consider a network graph representing a city's transportation system. Nodes, they are vertices, represent intersections or stations. Edges, they represent roads or train lines between the nodes. Next, problem. Let us move on to the problem. There is a question that is give the following adjacent matrix for a network graph. They have given an adjacent matrix. We have to give the following network graph for that. So, we have matrix A is equals to 4 into 4 matrix, which is 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0. So, when 1 indicates a direct connection between nodes and 0 indicates there is no direct connection between the nodes. So, we have to find the critical point, that is node or edge, that if removed will disrupt the connectivity of the network. Next, let us see the solution. First is we have to find graph representation. We have 4 nodes, that is node 1, 2, 3, 4, which is represented in the flower bracket. We have 4 connections with respect to node 1, 2, 3, 4. Node 1 is connected to node 2 and 3. Node 2 is connected to node 1, 3, 4. Node 3 is connected to node 1, 2, 4. And node 4 is connected to node 2 and 3. To find critical node analysis, if node 2 is removed, the network splits into 2 disconnected subgraph, that is 1 and also 3 comma 4, which is given in the flower brackets. Next step is we have to mathematically verification. We have to mathematically verify. We have to compute the degrees of each node, that is number of connection. That is, node 1 has degrees of 2, node 2 has 3, node 3 has 3, and node 4 has 2. So the highest degrees is of node 2, that is 3. So which indicates it is a critical node. So next is conclusion. Removing node 2 disrupts the network, making it as a critical point. So here is a graph, the solution, that node 2 is represented and it is highlighted to indicate its importance in maintaining the connectivity. Based on the example, this is how it looks. So next, let us consider a Python program for the above example. First, we have to import network as nx, import matplotlib.pyplot as plt, g is equals to nx.graph, nodes are 1, 2, 3, 4 and edges are 1, 2, 1, 3, 2, 3, 2, 4, 3, 4. Next, we have to add nodes and edges from nodes and edges. Next, we have to find a critical node, that is max of g dot degrees. Key is equals to lambda x, which is 1, 0. So POS is equals to nx dot spring levet of g. For we have to find the size, we have to give as plt dot figure of figure size is equals to 6, 6. I've given 6, 6. Next, we have to give nx, we have to draw the graph, or we have to plot a graph. So that I'm giving the command. At last, I'm giving the title as network graph with critical node, that is node of critical nodes. We have to highlight the font size with 12 number. That is, we will get a highlighted number of a critical node. Next, plt.show, which will give the output. As you can see in the picture, there is a highlighted node, that is the critical node. Thank you everyone. Please do like.